So this is a typical series parallel equivalent circuit type of problem. So there's no KVL involved, there's no KCL involved, no Thevenin, no Norn. So the question here is, what is the resistance of the following circuit as seen from the battery? So essentially they just want us to find the total equivalent resistance that is seen from the battery, so meaning the total equivalent resistance. Now I could totally see how we could, as a student, I can try to add these two together, try to work the problem, you know what I mean, from right to left, because that's what we do typically. But if we actually stop and look at the circuit, we would notice that there's a short circuit over here, okay, and there's a short circuit here as well, and there's another one here. What does that mean? It means that there's no current that would flow through here, this whole thing. So we can eliminate this part of the circuit. We can take it out. We don't need to include this into the calculations at all. Now, as you can tell, I can actually solve this problem within 1 minute. Another student that wouldn't notice that would actually, spend a little bit more time trying to figure out adding these two, and etc., etc. So don't do that. What you need to do is just realize that you have short circuit here. So that's the only trick here. This is a very simple problem, but I just wanted to kind of show you that in this kind of problems we don't necessarily need to work it and spend long hours trying to figure out what's the total resistance here. You can just notice it's just the same thing as if we had like a capacitor or an inductor. I think I've talked about it in earlier videos, where when you have a capacitor in a DC circuit, you have an open circuit. There's no current that would flow through that particular capacitor. And if you have an inductor in a DC circuit, again I'm talking about DC circuits here, then you would have a short circuit for that inductor. So I'm guessing here, if we had an inductor here, and an inductor here, we would have the same circuit here. We would short it out just like here, short it out, and take this whole part out of the circuit. So in doing that, we're left with only 3 resistors. So we still have the voltage source, okay, and the 6 ohm. I'm drawing really bad today, but you get the point. Okay, so I still have that. I still have the 6 ohm here, the 12 ohm here, and the 12 ohm here. So now you have a very much simplified circuit. You don't need to deal with any of these at all. It's out of the circuit now. So now I have these two are in parallel because we have a note here. They're not in series. That's a mistake that we as students we usually make. So there's a note here, so these two are definitely not in series at all. So 12, they're in parallel, times 12 over 12 plus 12. So this is 144 over 24, and that's 6 probably. Yeah, that's 6 ohms. Now these two are in parallel. The total would be in series with the 6 ohms. Okay, 6 ohm resistor. So now we can add 6 ohm, and the total would be 12. Okay, so this is just because I spent times explaining, but you can totally do this problem in 30 seconds.